Hello everyone, welcome to AI Anytime channel. In this new video, we are going to develop a fashion search application. Okay, so we are going to develop this Streamlit app where the end user can query about a cloth choices. For example, if I go on some e-commerce sites like in India we have Myntra, Flipkart, and we have Amazon, Zara, H&M, and different e-commerce or the fashion brands where we go and search for some kind of cloth, like give me a black shirt or a denim shirt, or a little black dress or something like that. So this is going to be basically a text to image search app. We'll see how we can use an embedding model, an open source embedding model, and create this application that will help us retrieve those images or the fashion clause from the database or the image base that we will have right from that those embeddings. Okay, so if you currently see on my screen, I am on Myntra.com, which is a e-commerce in India. I don't know if they operate outside India, probably. So if I search here something like denim jacket or something, okay, I just search on that, and you can see now I get a lot of denim jackets. This might work. I don't know how Myntra's backend works, but I assume that they would have a hybrid kind of a recommendation engine or a hybrid search mechanism uh, where they would be looking at the query, the input query the user is looking for or searching for, and then they will have a semantic search or keyword based search or also a image search. I don't have much idea about it, but I assume that an organization like Myntra or Flipkart or Amazon, they would have a hybrid search mechanism. Okay, because they don't have any open source, like a research paper or something like that, an open source algorithm. Amazon, I think, did release their recommendation engine in open source, but that's different story. So let's see how we can build something like this now, where we'll have an input search option and a search box, and where you can just go and query for some clause that you feel that okay, that might be in your database or something, and then we'll try to retrieve that dresses from those or the fashion clause. This is what we are going to build. So to build this, we are going to rely on clip vit, the vision transformer. Okay, so we have transformers and we have vision transformers, like multimodalities, right? So multimodalities of data, different scales of data that we have. For example, images, we have text, we have audios, etc. So if you see this, it says clip. OpenAI has clip, by the way. Okay, if you are not aware, they also have clip interrogator, etc., etc. So this is a kind of a, if you read it, says this is the image and text model clip. I'll just right click and open this here and let it open. By the way, you can see learning transferable visual models from natural language supervision, blah blah blah. Okay, so if you see this, which maps text and images to a shared vector space. Okay, so you have text and images. Okay, and it's basically they get saved in a vector space, or basically wherever you are trying to store those in a shared space. And for applications of the models, have a look in documentation. So it's available on SBERT as well, sbert.net image search. You can have a look at that. But in this video, I'm going to use something called Haystack, and a lot of videos now, I think next 4 or 5 videos in LLMs will be related to Haystack. So Haystack is a framework by DeepSeek, and they are a very strong competitor of LangChain. So I have used Haystack couple of years back when there were no people were not going gaga about generative AI or LLMs. Couple of years back, we're still with NLP, the bot models, the robota, etc. We're working with Haystack on couple of applications that we built. But I'm going to leverage Haystack and combine that with Clip VIT and see if we are able to develop a cool application, a hobby project or a fun project in this weekend. So let's do that. Okay, so again, we are going to use this from sentence transformers. We have different embeddings model inside sentence transformers. We have MPNet, we have MiniLM, we have Clip, we have multilingual E5. A lot of them embedding models are available. Depend what you want to do, guys. Okay, so now what I'm going to do here is I'll also show you what Haystack is. So Haystack is by DeepSeek. Stop using LangChain, guys, in production. I'm a huge fan of Harrison Chase, and I hope people will not kill me after this when I say, stop using LangChain in production, because there's a lot of issues with LangChain. But I'm a huge fan of the entire LangChain, and I'll say the community as well, the LangChain community and people who have contributed to LangChain. Without LangChain, we would not have come so far, trust me, this faster with this speed that we have. with so many integrations and what LangChain has done with generative AI ecosystem, but we have to look at other options when we want to scale your solutions or you want to build a production ready applications with large language model. And if you see it, it says open source LLM framework to build production ready applications. And you can read about their GitHub repository, something on the GitHub repositories as well. They have tutorials, they have blog, etc., etc. So let's build it. So if you see, currently I am on my VS Code, and let me just show the directory. So I'll show you the directory. So this is the directory that I have. It's called Fashion Search App, and in this I have a virtual environment that I have created. I have a requirement files. I have a new data. So let me just go inside new data, and I'll show you some items that I have, like the data that I have, the data of clause. Okay, this data I have downloaded it basically, from Jara websites. Okay, so I have went to a couple of their websites or the sections of website, and I have downloaded all these like items of clothes like denims and I don't know what kind of clothes. There's sweaters, hoodies, etc., etc. Okay, you can, if you see, currently I have 35 items. You can have 35,000 items, depending on what you want to do with this. Okay, now I'll just go inside my VS Code, and you can see a requirements txt. These are the things that you need. The minimal requirement, the farm haystack. This is the main core of your entire application that we are going to build. We need Streamlit for an interface where we will build it faster. You can use anything you want, React or whatever, depending on what you want to do. We have Torch as a backend that will help us use that clip VIT model and sentence transformers, of course, to load that. And yeah, let's create a file called multimodal search, multimodal underscore search.py, and then I also create an app.py. Now what I'm going to do is I'm going to write all of my like the multimodal search logic inside a class. So I want to build this as a modular kind of a thing where I can use the same class later on in my other videos that I'm working on. Okay, so that's what I'm going to do. The first thing that we have to do is we have to import OS, because we need that file path, the new data file path that we have. So let's do that. So we have import OS. Then what we have to do is we need a few things from Haystack. The thing that we need is, I don't know why I have given space. So from Haystack, so let's do that. Let's first import document. We need some document object. I'll show you the store, where we're going to store those the data that we have, the images. Okay, so from Haystack import document. We also need pipeline from Haystack. So from Haystack import pipeline. I use tab9 guys for completing as an coding intelligence assistant or something like that. Okay, so from Haystack import pipeline. The next thing that I need is, so let's see, so from Haystack dot document underscore stores, we need a document store. This is basically the object. Okay, so document stores import, and these document stores are nothing but they are vector stores. We recently would have worked with ChromaDB or FAS. Those are in memory vector stores. Everything is in memory. But if you need a vector database, you have Pinecone, you have Milverse, you have Qdrant, you have Viviet, a lot of other things as well that you can utilize. You have AWS Open Source Service if you want a closed source scalable vector database. Okay, now here what we're gonna do is import in memory. So let me see if it suggests something like that. Okay, it's not suggesting, so bad. In memory document store. Now I got it. Okay, so from haystack.document store, what else we need? We need a retriever. Okay, to retrieve that, right? So from nodes. Okay, so let's do that. So from haystack dot nodes, and then we're gonna use retriever. So I hope it's RIEVER. Okay, retriever, and we're gonna use a multimodal module here. Okay, so multimodal. I'm just gonna use import multimodal retriever or something if I have. I don't know why it's not suggesting multimodal retriever. Let's see. I hope I spelled it correctly. IEV. Okay. these are the requirements that we, like these are the libraries or and the modules that we need basically to create this shared vectors that we have, of your images. So create the embeddings first, and then you have your embeddings as a base, knowledge base or the image base, and then user comes up with a query and you can search. Now let's write a class. So I'm just going to write multimodal retriever. Let's remove the retriever, make it search, little easier to understand, depending on what audience. Not everybody will be an expert, right? So people like me who doesn't understand much, but class multimodal, I don't know why I have written modal, it's modal. Okay, so class multimodal search, and so let's have an init function. So def init self, fantastic, and that's it. And now we'll write few of the logics here, guys. So let's first initialize the document store, to store the image embeddings. So it's basically what we do. We have images like in the new data, right? We have to create the embeddings which are basically in a lower dimensional space. So focus on the word dimensions because we are going to define here. So def init. So what I'm going to do is self dot document underscore, yeah, fine, let's use this. I'm going to use this in memory document store, and here I'm going to define, I'm going to use a parameter that's called embedding dimensions. So let's use that, embedding underscore dimensions, so dim, and I'm going to, it's going to be 512 in this case. So embedding dimensions, depending on what model that you use, guys, for embeddings, that's how you define the dimensions of your embedding. So embedding dimension, this is going to be the dimensions of the image embedding, which is 512. Okay, now this is done. So let's define our document directory, which is our data folder. So this is nothing but something called new underscore data. In the left hand side, if you see the file span, here you can see the new data, which contains 35 images, which are my source data. You can have 35,000 images, but make sure that might crash your in-memory document store. You need a Elasticsearch or fast or something like that, to work with. Okay, I take the word fast back. Okay, Elasticsearch, Pinecone, Qdrant, Milvus, etc. Okay, now doc directory or Supabase as well, you can consider that. Doc directory, new data. Now what I'm going to do is images, and inside this it's going to be a list, and inside this I'm going to call this, okay, document. So what I have to do is I have to fetch all the images from new data. I have to write it in that. Okay, so I have to write that in a document store. So let's write the logic for that. So the first thing is content. So content, and let's, excuse me, I got a call. So document f doc directory. Okay, this is right, doc directory. Then what I have to do is I have a file name here. So let's define that file name, and after that file name, Control G, file name, I'll come out of that and I'll give a content type. So my content type is nothing but image. So let's just write image here. That's it. You put PNG, you put whatever, it's okay. Now come out of this thingy here from document and just do for file name, correct, doc directory, or let's do it in a better way. So file and dot and then slash, and then we define our doc dir. That's it, and we are done, guys, here. Okay, but here I missed that ending here, so let's end this, and that's it. So now what we are going to do is we're going to write this all inside a document store. So we're going to use a write underscore document, so write document module from Haystack. So let's do that. So self dot document, so let me just do that, self dot document store, and I'm going to just do write underscore documents, and here I'm going to define images. That's it. Okay, self dot underscore document store, write document, and now this will write all of those images in a document store. Now what next we have to do, we have to write the retriever logic. So let's do self dot retriever, and self dot retriever underscore text to image. Let's use that text to image module, text to image, self dot retriever text to image, image. Now we're gonna use multimodal retriever. So this is the module, multimodal retriever module. I don't know why it's multimodal. it's multimodal. That's why it was not suggesting. I have imported it wrong. This will be multimodal retriever, so let's make that change. Multimodal retriever, and here in this module we're gonna write the logic for that variable that we have, retriever text to image. Okay, so let's write it. Multimodal retrieval. The first thing that I'm going to use is my document store. I'm going to define the document store. My document store is nothing but that is your self.document store, which is correct. I don't know why it's document stores, because I have defined as document store perfectly fine. The variable is okay. Now document store, then I'm going to use, let's define a variable called query embedding or something, model. And here we define the model that we're going to use. So we're going to use sentence transformer, or let me just copy that. Otherwise I mistype it something, so it will give me error. So you can also download that model locally, and you can also load it that way. But this, when you are running it for the first time, you need internet connectivity, because it has to download all the model weights and keep it in your cache folder. Excuse me. Query embedding, and what I'm going to do next is I'm going to define a query type. So my query type is nothing but it is text. So let's do that here, text. And what I'm going to do is, here comes document embedding models, and here I'm going to define a key value pair, so image, and I'm going to say sentence transformers, click perfectly fine, and you can see this makes sense. And that's it. Okay, let's do that, because now we have our self.document store .write document has been written. Then we also have retriever text to image logic done. Now what I'm going to do is I'm going to turn images into embedding, okay, and store them in the document store. So let's do that. So I'm going to do update the embedding, so self, and you can keep on adding multiple images as well, and this will get updated. So document stores, self.document stores, and update embeddings. So let me just do that, update embeddings. Here I'm going to writing update embeddings, and here I'm going to do retriever, and retriever is nothing but self.retriever text to image. That will basically update that embeddings that we have in the line number 9. We have defined self.document stores, and line number 26 we are saying okay, self.document store .update embeddings, and use the retriever here on the line number 19 that we have. That's what we are doing here, guys. And now let's use a pipeline. So let's self.define a pipeline. So it's self.pipeline, and in self.pipeline I'm going to initiate a pipeline here, just an empty pipeline by now, it's okay, pipeline. And what I'm going to do is I'm going to add some nodes, and that's how the logic of Haystack, right? That's how it works. So self.pipeline .add underscore node, and here inside this node what I'm going to do, I'm going to use a component, so add a parameter, and in this component self.retriever text to image, and I'm going to call it a name, and this name is, let's call this retriever text to image, and alt G to come to next line, self retriever text to image, and just gonna give an input as well. So let's define an input, and it will be list query. Okay, and we are done with this add node thingy. Now let's just write a function, guys. Come out of this and just write a function. So what I'm going to do is I'm going to write a function called def search function, and inside this search function I'm going to do the self query and number of returns, like number of sample you want to return, so top k, which is basically a document in this case, top k equals 3, and just do let's have a variable called results, and we're going to run this pipeline. So self pipeline dot run, and inside this run what I'm going to do is query equals query, and I'm going to pass some parameters. So params equals retriever, so retriever, I always mistype retriever, so params retriever text to image, and then I'm gonna use a top k here, so top underscore k, and this is going to be my top k, so let's just write top underscore k, and that's it. I think we are okay. let me see, query equals query and params equals retriever text to image, and I don't know where, I think I made some mistakes. This will not be here. Inputs k, top k equals top k, retriever text to image. This it will not be end here because this comes together. Yeah, this looks nice, excuse me, sorry. And now what I'm going to do is I'm going to return this and sort this with the highest confidence score or something. So return, and let's do a sorted, and in that results, and inside this result I'm going to pass my, let me just first write it, document. Maybe I have to return that documents as well. And I'm going to use, let's do it in this way. So key lambda d, and we'll have a document dot score. So d dot score, and just reverse equals true. That's it, and we are done with our logic, guys. The multimodal search.py file which we have now. We can use this multimodal, we can make changes here, and it has nothing to do with your front end or whatever you are using, okay, to basically call this class. Okay, we are going to call this class in our app.py. Okay, so let's now go back to app.py, and here we'll write all of our logic for app.py thing. In app.py, the first thing that we're gonna do is import Streamlit, which is our Streamlit is a Python library, help you build faster data science applications. That's what they were using previously. I don't know what's their current pitch, but import Streamlit as ht. And the next thing is from multimodal underscore search, which is our file name. You can see in the left hand side, multimodal search. I'm going to import that class that we have, multimodal search, and now we'll be able to use all of the functions from multimodal search.py file. What next we have to do is I'm going to write a main function for a Streamlit application, and inside this I'm just going to write pass for now, and in below section I'm going to use if underscore name underscore equals main, right, just to run the main function. And here I'm going to write all of my code logic. The first thing that I have to do, I'm going to set a title for the app. So I'm going to use a markdown. So let's use a markdown because that's what Streamlit supports. st.markdown, and here I'm going to have an h1 style, little bit of styling, h1 style, and I have a center text align, so I'm going to use text align center, and after that I can also give it a color. So let's give a black color, or probably a green color might look better, I don't know. So let's use a pink color, guys, and see if that makes any sense. Color pink, and then have a font size. I don't need font size, it's okay, color pink, but you can give font size, and h1 style to color pink. And now what we have to do here is you can also basically write our, I forgot to use the right formation. Okay, now yes, h1 style, and in this now what I'm going to do, I'm going to basically use a name for this app. So let's call it fashion cloth search app. This is what I'm going to call, and I'm just going to end this h1 tab. Okay, fantastic, this looks good. And to use a markdown, I want to do an alt G here. To use a markdown, you have to do unsafe allow HTML. Okay, so let's do that. So unsafe allow HTML, and that's equals to true. So let's do that true. So we are okay with our name, and I also realized that if you use this, it will probably use the I'm not sure if a container Streamlit, right, it will use the container. What I have to do is I'm going to set the page configuration. So ht.set underscore page config, and in this page config what I have to do is I have to basically set a layout, and in this layout I'm going to do layout equals wide, and in this it will give me the entire layout that I can utilize it, right, to show the results and all. ht.set page config layout equals wide. You can also do page icons, page title, blah blah blah, you can do that. Okay, let me see what's that. Is it page underscore title? I don't know. Okay, hopefully that should be page underscore title, and I can write fashions excuse me, fashion search. That's what I'm going to do, paste item. Now we have the markdown set. Now what we're going to do is, let's use that class here. Okay, so multimodal search, a variable, I'm going to use that multimodal search here. Okay, now inside this, now we need a input box, so let's call this query, and my query is nothing but going to be ht.text input. So let's do that text input, and in this text input enter your query. Enter your query. Fantastic. Okay, and here what I'm going to do, I'm going to say, okay, if ht.button, I'm going to have a search button kind of a thing. Inside that I'm going to write my code now, logic. So let's do if length of query greater than 0, then only execute that. So if there should be a value, there should be a query inside that input box. If there is no query, please don't execute that button. Okay, so if length query greater than 0, results, and my results are multimodal search dot search. That's the function that we have defined, search that we have defined, and here we're going to pass our query results. Now this gives the result. So let's have ht.info, and here we're gonna say your query was then it's, we can give some one space and then some write query. It's a string, so don't have to do that. I think that will probably work. And then let's have a subheader, ht.subheader, and inside this subheader I'm going to write search results. Let's make this capital, search results, that's it. And now let's have few columns, column 1, column 2, column 3, and inside this ht.columns, and let's write 1 cross equal distribution to all the columns. You can probably ignore that, but that's how I do, just to make sure I can better track it. Now in column 1, what I have to do, I have to we have to write the first code for the first column, and then we'll copy it for other columns. Because if you see here in our multimodal search pie, we have our top k is equal to 3, so we will basically get three results, like 3 document, which is your 3 images. Okay, so we have to show that in 3 different columns. It will look nicer on the Streamlit interface. Now ht.write, let's just do f score. Your score is, and that's basically, we can also round that, so let's do a round. And now I'm going to use a round function because it will give me, score till decimal points or something. So I need round, it will give me to 2 decimal point. And so let me just do score, and I'm going to multiply this with 100. Yeah, so we'll get the percentage of that, how, like what is the percentage confidence similarity of that query with that image that we have. Score 100. And what I'm going to do is, I'm going to get this on 2 decimal point, and that's it. That's what, guys, so we can do percentage. Okay, so we're gonna write percentage, that's it. ht.write, and let's now show the image. So that will come from document store. So ht.image, and I'm going to say results 0, not dot image, it's your content. So let's do the content and use column width true. Use the entire column width. No, it's not really capital. Use column width equals true. That's it. Now we're gonna copy this entirely for column 2 and column 3 and just make one change. This is for column 2 and this is for column 3. So let's make changes here with column 2, and this will become your column 3. And inside this will become your, basically this is the second one. The index starts from 0 and that becomes your third, sorry. Yeah, that's it. And of course, sorry, this result also has to be results 1 and this results 2. And we have an if here, if length query. And now what I'm going to do is, let's write an else statement for error or something. ht.error, or let's use warning, probably it's a status message, please enter a query or something like that. Okay. Please enter a query. Okay, and that's it, and this is what we are doing here, guys. We're just gonna using our multimodal search, and then we have query ht.text input, enter your query, and then we have a button, and we say okay, if query is greater than 0, there's a value inside it. We just execute that multimodal search function, pass the query, then we have info, your query was plus query, and then subheader, which is your search result, then 3 columns, and inside this column what we are doing is we are rounding it to 2 decimal points. We're just getting the results. You can see it over here with result 0 and then 102, and then that's it. That's what we are doing in this, guys. So let's now run this. I think it's okay, let's run this now. So Streamlit run app.py. So you can see it's running. It says I'm running. Okay, so you can see a cycle of something here icon on Streamlit. Basically they use it. You can all hide it completely. You have to change changes in the config.2ml and all those files of Streamlit. Basically you can do that. You can set it your thingy and everything as well. Okay, now you can see that this is what we have over here. We get our fashion search, and you get your enter your query. So let's do first one thing. Let's do, I'm gonna just do LBD. Once I do LBD, it says again running. And by the way, I'm running this on a CPU machine. I don't need a GPU for this embedding model that we're gonna using. At least to run it, and it takes around 20 to 30 seconds, and you can see fantastic, because I searched for an acronym, by the way. LBD means little black dress, and if I don't know, I think it was suggested by a female friend to make this query. And if some of my female subscribers are watching, please let me know if we have something for men as well, like LBD, little black dress, and I don't know why the men can't get this acronym, right? LBD, little black dress. We cannot think of it or something like that. Okay, and if you see, we got our results, like search results, and these are the little black dresses that we see. Probably it's fantastic, right? So I'm not writing all the text as well, like little black dress, only LBD, and I got these responses. This is the way I wanted to test it out. But you can see the scores: 55.99%, 55.39, 55.07% or something like that. And I got the result. Probably if you want to extend this app further, you can add a lot of other values, like you can create a CSV or a JSON file, and you can have an unique ID for all of these dresses, and basically your document ID, by the way, right, in that case. And then you can also return those values with it. Okay, so basically this is fantastic, to build these applications further. Let me just look at one thing. So I have this ht.markdown, h1 style, and then text align center, and then color pink. Let me basically replace this pink also. I don't know why I'm not getting. Okay, I have missed this, and now it looks good. Okay, fashion clothes search application. I'll just go ahead and I'll just do a rerun, and now you can see we got our fashion cloth search application. The value is there, that's why it got executed as well. Fashion cloth search application. Now what we can do in that case is, we can also you go to settings, you go to system settings, you can go to dark, and here you can see this is how it looks now. But you can also make these changes from config.2ml file as well. LBD. Now let's search for denim jackets. So I'm going to search for denim jackets, and once I search for denim jackets, you can make it more conversational, more human-like conversational. You can use a large language model, combine that with it. You can also give options to accept multiple parameters, like your age group, if you are going for adventure, what kind of patterns you are looking. That can be your slider and all, where user can input it, and you can make like a chat bot. It will be very cool idea to work on, right? This is what I searched. So you can see here, if I search denim jackets, it shows me all the denim jackets. But this will probably come from a lot of other parameters that they will have. They will have filters, they will have tags, they will have keyword based search, they will have semantic search. So it will be hybrid. That's how I assume, the companies like Myntra or Flipkart or Amazon But here we don't have anything. We are using a simple embedding model, clip vit, and we build this fashion cloth search application. Now you can see I searched for your query was denim jackets, and I got the results for denim jackets. So you can see this is a denim jacket, this is a denim jacket. I don't know, probably I only have 2 denim jackets in my input database, like 35 data source that we have, 35 images in the database. That's why. But you can further improve this, guys. This is what I wanted to do, in this video, to build this cool simple application for you, and you can take this and extend it further. And remember, we have built this with Haystack. This thingy, you can see we're using Haystack from DeepSet, and we're going to also use Haystack for a couple of other simple use cases that we're going to work on, when with large language model. So the code will be available on GitHub repository. You can find all the code on GitHub. Let me know what you are building with this. You extend this further, or you integrate it somewhere, through an API or something. I'll be more than happy to hear that. And if you have any thoughts, comments, or feedbacks, please let me know in the comment box. You can also reach out to me through my social media channel. You can find that on YouTube channel About Us or YouTube channel banners. Okay, that's all, guys, for this video. If you haven't subscribed the channel yet, please subscribe. Watch my other videos in the LLM playlist. You will love it. And please share the channel and videos with your friends and to peer. Thank you so much for watching. See you in the next one.